All right. Still section 3, but day 2. We're breaking it down nice and slow for you. Still talking about tangent to a curve, but let's add an additional thing to it. If we know the slope of a tangent line, then we can write the equation of the tangent line. So yesterday's lesson, we just did slope. Now we're going to work on finding the equation of the tangent line. To find the equation of the tangent line to the function x cubed minus 2x squared plus 3 at this point, 1 comma 2. So in order to get an equation of a tangent line, you need two things. You need a slope and you need a point. Well, they gave you the point. The point is right here, 1 comma 2. We just need to find the slope at that point. And so we do just like what we did yesterday, where you find the slope, you're taking the limit as x approaches 1. Where am I getting the 1? Because that's the x value of your point, of f of x minus f of 1 all over x minus 1. Remember, this is just the regular slope equation, y minus y over x minus x. You're plugging in f of x here and f of 1 there, and then x minus 1, and we're taking the limit as x approaches 1. All right, so then what we do is we replace that f of x with this function. So you replace f of x with the x cubed minus 2x squared plus 3, and then where am I getting this minus 2 from? Because f of 1, here they give you the point that when x is 1, then y is 2, so that's f of 1 is equal to 2. So you got that. And then that gives us x cubed. I simplified it. 3 minus 2 gives you a plus 1. Now you're going to factor it. How do you factor a cubic? Well, here's the deal. I'm pretty confident that x minus 1 will go into this, so that's what I would always try. And you can do synthetic division is going to be your easiest, or you could do long division. Divide this x cubed minus 2x squared. There's a missing little 0x there, and then plus 1, and divide it by the x minus 1, which if you're doing synthetic division, it would be a 1 in there, and it ends up factoring as x minus 1 times x squared minus x minus 1. The x minus 1's cancel, and so you're taking the limit of x squared minus x minus 1 as x approaches 1. Plug a 1 in there now, and you get negative 1. So that's the slope. This is the slope of the tangent line to this curve at this point. It's the slope of the tangent line. All right, so now that we've got a slope and we have a point, then we're going to plug it into point slope form. Y minus y1, your y1 was 2, equals m, which we found was negative 1, times x minus x1, and your x1 was 1. And we're just going to leave it like that. That's what we do next year in calculus, is we're going to leave it in point slope form. And so you can just leave it. All right, so back to an original question. How to find the slope of a curve. It turns out that the slope of a curve at a point P is equal to the slope of the tangent line at that same point. And so the slope of a curve might vary from point to point. In fact, it usually does. So it's helpful to be able to represent it in a generic form using an arbitrary point, and then we can use it to find specific slope values. So what I'm going to do now is I'm going to find the slope of a curve just in general for a function, right? And then it doesn't have to be at this specific point. And then when we are given points, we can just plug those in to find what the slope is at each of these points. All right, so let's find an equation of the line with slope 5 tangent to the graph of f of x equals x squared plus 3 minus 1 plus 3x minus 1. All right, so this time they gave us the slope, but they didn't give us the point. And so I'm going to use general terms, f of x and f of c, to represent my 2 points. And so I'm going to take the limit as x approaches c of f of x minus f of c all over x minus c. So that's that same formula we've been using. It's just this time they didn't give us a point, so I don't know what x is approaching here. So I'm just going to let it be some, c is representing some x value. All right, so I'm going to plug this in. Yeah, f of x is just this guy. That's where this is f of x. And then you're going to subtract from it f of c. But f of c would be just plugging a c into all of these x's. So that's where I'm getting the c squared plus 3c minus 1. I plugged c into the x. Well, that looks like a big old mess, right? But let's simplify it. When you distribute this negative sign, you'd have a minus c squared, a minus 3c, and then a minus a negative 1. So the minus 1 and the plus 1 will cancel. You're just left with the x squared plus 3x. Make sure you've distributed the negative to the c squared and to the 3c. All right, now, just like before, what I really want to do is cancel this x minus c, because you can't go plugging in a c into x here. You'd get a 0 over 0. So what I noticed is I could group these guys together, right? So I just rearranged them a little bit. I rewrote it as x squared minus c squared here, and I grouped the 3x and the minus 3c together also. And if I factor by grouping, x squared minus c squared, that's the difference of two squares. And so that the first two terms, it factors as x minus c times x plus c, because that's the difference of two squares. And then the second two, the last two terms, have a 3 in common. So I'll factor out the 3. So I've got that, and then what I really want to do is cancel this x minus c. Well, I have a term, the first term has an x minus c factor, and so does the second term. So I'm going to factor out that x minus c from both of these terms. And when you do, you'd be left with this x plus c and then plus 3. So that's what I did here. Factored out the x minus c, and you're left with x plus c plus 3. And now the x minus c's will cancel. Nice. And then I'm taking the limit of x plus c plus 3. As x is approaching c, now I can plug in the c into the x, and you get 2c plus 3. So this is giving a general slope for any point on this curve. This curve is a parabola, right? And I talked about it yesterday of, at the vertex you get a slope of 0. Before it's negative, after it would be a positive slope. So this gives me, in general, any x value, I can find what the slope is at that point. Now, they wanted us to find the equation of the line that has a slope of 5, right? So what I want to do is find, what's that point? What is the point when my slope is 5? So what you'll do is you'll set the slope we just found, 2c plus 3, equal to the slope they gave us, which is 5, and solve for c. And so you would subtract the 3 from both sides and get 2c equals 2, and dividing by 2 gives you that c is 1. So this is the x value when your slope is 5. To find the y value, because we need the point, you'll plug this 1 into your f of x, and so you get f of 1 would be 1 squared plus 3 times 1 and then minus 1, and you end up with 3. So the point on this curve that has a slope of 5 would be 1 comma 3. They want the equation of the line, so I'm going to use point slope form. Y minus y1 equals m times x minus x1. And so it's y minus, your y1 was 3, equals slope is 5, m times x minus x1. And so there's your equation of the tangent line to this parabola that has a slope of 5. All right, here's your homework. Your tan line is showing. Cute. All right, I hope you all are having a fabulous day.